Hey, this is Mrs. Williams, and this question comes from the 3.11 quiz. It says Michaela drops a ball vertically from a height of 80 feet. The peak height after each bounce is half the previous height. How far does the ball travel from the time she drops it until it reaches the peak height after the fifth bounce? So in all actuality, I really think the easiest way to solve this particular problem is just to think about it. Let me grab my pen. So we're going to draw kind of what's going on. Michaela, let's say the ball starts here. She's going to drop it, and it's going to come down wherever the ground's at. And it's going to bounce back up, and each bounce is half the previous height. So the next bounce will be about there. The next bounce will be there, and it'll come up about half that high the next time, and so on. And we want to know how far the ball travels until it reaches the peak height after the fifth bounce. So if you look right now, I only have 3 bounces. So we're going to have to go fourth bounce, fifth bounce. So this is the first bounce, second, third, fourth, fifth. And we want to know how far the ball travels from the time she drops it until it reaches the peak height after the fifth bounce. So this is a very tricky question. It's actually right there is between the ball starting at 80 feet up here and ending here. So that got to be really careful. The peak height after the fifth bounce. So it's really it's really detailed. You got to be careful there. So if we think about this, we don't really need a geometric sequence to do this particular type of question. It would come in handy, if it's a different question, it could be the same situation, just a different type question. Um, for example, if we wanted to know what the height was at, or if we wanted to know how many bounces it would take to reach a certain height, that would be a different question. A geometric sequence would be helpful, and I'll show you in a second how to write that. But for this particular question, I think it's just easiest just to think about it. So if you have 80 feet, and we're just looking for how far the ball travels, so let's just trace the path the ball takes. This is going to be 80. So we have 80 feet that the ball has gone. And then we know that from this bounce to this height is 40 feet. So the ball from here to here is 40 feet, and then back down is another 40 feet, which is another 80 feet. And then again, we know that each bounce is half as high as the previous, so we know that this height is going to be 20. So starting from here to here is 20, then back down is another 20 for a total of 40. From here to up to the next bounce is half of 20, which is 10. And then back down would be a total of 20 for that bounce. And then we come up to here, which would be half of 10, which is 5. So this entire bounce is 5 plus 5, which is 10. And then we want to go back up just to the height, the peak height there. And so that is going to be half of 5, which is 2.5. And so if you total all of that up, let's do that. $232.5. So that is how far the ball goes, 232.5 feet. And that would be the answer to that question. Now if it was a different type of question, you can actually write an iterative rule for a geometric sequence. So the iterative rule in general is a sub n equals a sub 1 times r to the n minus 1 power. So for this particular question, let's say we wanted to know what the height was at the at the fifth peak, we could say, okay, well, we want to know a sub 5. We know a sub 1, the initial height is 80. And we know that the ratio is half each time, so we could write it as a fraction 1/2. We could write it as 0.5, but that's going to be your r value. And then n minus 1 would be 5 minus 1. And so if you simplify all this, be 0.5 to the fourth power, you actually get 5. So what this means is that on the fifth bounce, now this is a little bit different. You're not looking at the fifth lowest point. This is the fifth bounce because we put 80 in here, which is the peak height. So 80 is your initial peak height. We're looking at the fifth. We're saying what is the height of the fifth one. So this is the first bounce, second bounce, third bounce, fourth bounce, fifth bounce. And so you can see that you would get the height at that fifth bounce. So depending on the question, you know, a geometric sequence can be useful, but for this particular one, I think it's just easier just to think through it rather than try to come up with a formula for it. So I hope that helps. Let me know if you have any questions.